Yes, hold on just 1 second because Ryan asked first. And yes, so let me write the problem. What was it, Julia?
It was S of t equals negative t squared plus 2, plus 2t plus 5.
Okay. So so was it different than this one?
Yeah, I got a little confused starting it off.
Okay, very good. We'll look at that. And Ryan, what was your question?
I was wondering if you could go over number 18.
Section, page, anything. Give me anything.
I believe it was section 1.8, so it was page.
Okay, I got it. (1.8), problem 18, and here it is. So we have f of x equals 2x to negative 2, and it's asking us to find the second derivative. Okay, so let's start with this. So f prime of x, bring down negative 2, so negative 4, x to negative 3, subtract 1 from the power. The second derivative, bring down negative 3, 12, subtract 1 from the power. Anything else on this problem? 18?
Wait, so after I find the first derivative, I then use the first derivative to find the second one.
There is the second derivative is the derivative of the first one.
Okay.
Good. Is that okay?
Yes, thank you.
Perfect. So let's look at problem 2. Which was this? Which I'm assuming is from the same section. Is it?
Yeah, it's section 1.8.
Yes.
I think it's at around page 179 or 180.
So which problem is it?
Just give me a moment to pull it up.
It's okay. Is it from the book, or is it?
Yeah, it's from the book. Yeah. It's asking for like B and A.
Right. So V of t is negative 2t plus 2, and A of t is negative 2. It doesn't matter. I don't need to see the problem. But is that?
How did we get that?
How do we get the velocity from the distance?
Yeah.
We bring down 2, we multiply by negative 1, we subtract 1 from the power, we differentiate 2t to get 2, we differentiate 5 to get 0.
Oh, so it's the same thing as the other derivative. Oh, okay, I get it.
So this was the problem last time. And that's what we did. 2t minus 1/2. Then we differentiated the distance, the velocity, the derivative of the distance, and we got 2.
Okay, now I get it.
Okay. Anything else?
I have a question.
Yes?
For number 18, I put 12 over x to the power 4.
That's perfect.
Right?
12 over x to the 4th is also good.
Okay.
Absolutely. It's the same thing.
All right, thank you.
Thank you. Anything else? Other questions? Please, anything. Okay.
Can you go for number 60
yes?
on page 172?
Yes, with pleasure. 60 on 172. 60, 167, 172, 60, 60, 60, 60. Total cost. Okay. So total cost function is given by C of x equals 2,000, and I see x squared plus 2 to 1/3. Let me know if I'm copying the correct question, because sometimes where C is the total cost in thousands of dollars of producing X airplanes. Find the rate at which the total cost is changing when 20 airplanes have been produced. This is the function, correct?
Yes, that's it.
Okay, so basically the problem is asking us C prime of, what was that, 20. This is what we are asked to find. But I cannot find C prime of 20 before I find C prime of X. And the rule says, bring down 1/3, 2,000 divided by 3, subtract 1 from the power, 1/3 minus 1, negative 2/3, times the inner function prime. And 700 prime is 0. So in short, 2 times 2,000 will be 4,000, x, or simplified a little bit, times x squared plus 2 to negative 2/3. Are these steps clear? Is there any question here before we plug it in? Because now we have to plug in 20. 20.
No, that makes sense.
So do I need to show what we get when we plug in 20, or is it okay?
Yeah, that's okay. I ended up with 4,000x over 3, and then in parentheses x squared plus 2 to the 2/3.
In the denominator.
Yes.
Yes, it's the same thing.
Okay,
Just
perfect.
carefully plug it in. So when you, I am clicking here, clicking. So I just want to share my screen and show you how to enter it just quickly. So I would enter it because it's just one value. You know me, I like to see the function, yada yada. But since this is just one calculation, you have to be very careful how you enter it. So you have in parentheses 8,000, 80,000 divided by 3. Close, open, 402. Close the parenthesis. And I recommend, depending on the calculator you have, I recommend parentheses around the power, especially if it's negative. This calculator may not require parentheses for the power, but I don't trust it myself. It's just easier for me to keep it clear. So this is the answer, 489.573. We have to look and see, it says total cost thousands of dollars. So this is 573.64. So this is 489,573.64 dollars. So careful how you enter it in the graphing calculator.
So I answered 489.5736, and then for the measurement unit, I just said thousands of dollars per unit.
Per unit, it has to be dollars per unit, yes.
Yeah, but I did instead of 489,000, I did 489.573, and then the measurement unit, I said thousands of dollars.
That's fine. That's fine.
Okay, perfect.
Both are correct. Other questions for me? Very good questions. Thank you. See, if you work on these problems, you always have questions and we always have a good interaction. I love the interaction. I love answering students' questions and having discussions. That's why we are here, to communicate on topics. Awesome. Other questions for me? Anything else?
I just have a quick question.
Sure.
Can you put that paper?
Sure. Oh, yeah.
Just for an example, like for number 1 that you did for us, is it acceptable on the test to leave it as 12x to -4, or does it have to be changed to that fraction?
Sometimes if the problem says fully simplify, this is preferred. We don't really like, in general, we say that from algebra, we do not like negative exponents. No negative exponents. Also, if you get used to x to -4 written as 1 over x to the 4th, you will always be able to go back and forth between these two, because this is very useful. We've used it so many times because this is more difficult to differentiate. So if we're asked to differentiate the third time, find the third derivative, I will not do this. I will not differentiate this, but differentiate that. So every now and then we have to be able to go back and forth. Will I deduct points if I didn't specify no negative exponents in the final answer? Maybe not. I would say no. But normally we don't like negative exponents. For this situation, for a second derivative, it's okay. Good, very good. Other questions? Other questions? Is there anything else? Okay, perfect. So now you tell me, we're trying to go through all these in 1 hour from now, but we maybe or maybe not. So you tell me what you want me to do. I think we should skip the average rate of change because we've done that many times, but you tell me whether it's a yes or a no. Can we skip the average rate of change? Well, I don't know what to do if no one says anything.
Can we just do one problem?
Right, we can. I'm just saying that we have so many problems and this is just the slope of the line. We can, there is no problem. I picked some problems, so 52 and 135. 52 and 135, what does it say? So we have the total revenue. So we have a total revenue which is R of x, negative 0.001 x squared plus 150x. And they're asking us to find the average rate of change between 300, 300, and 305. How do we do that? Anyone, please? How do we do that? I really want to get to all these if possible, and especially the ones that are super important. The average rate, the differentiating within using differentiation rules on these. These are the core and the continuity. Can anyone tell us how to do this? Anyone?
Don't you just plug 305 in for x?
Absolutely. So I have to find R of 305 and then R of 300. And how do I determine the average rate?
You subtract the 2.
Yes. How do I write it?
Oh, sorry. Negative 0.001,
Yeah,
and then
that's fine. So let's say we get whatever. So it's R of 305 minus R of 300 divided by 305 minus 300. And it will be, of course, in dollars per unit. Is this okay?
yeah.
Okay, let's move on. So this is done. What else would you like to continue with? Piecewise defined function is very important.
Can we definitely go over the continuous and
Continuity and differentiability from graphs. Okay, so I was looking at 26 on page 144.
because there were some like problems that didn't have to do with graphs in that like section that was a little confusing, if that makes sense.
So let's choose from there. Anything you want to choose. So I am opening right now. I hope I'm not logged out. I am not. So this is in chapter 1, and this is the continuity is set from page 140. It doesn't matter which one because I have the page number. Okay, 144. 144. Okay, so you tell me what I wanted here is to look at graphs.
I think it was in 1.4.
Section 1.4.
Yeah, is what I had a question about. But if you want to do something from this chapter, that's fine too.
So do you remember the page number?
No.
Because
But it
section
you put the questions-
1.4 is on page 144. It just didn't take the page number for some reason.
Oh, gotcha. Okay.
So I had 26 in mind. So let's go to 26 and then we'll discuss your problem, whichever you want to pick.
Okay.
So in this graph, just looking at this graph of this function, we would like to identify where the function is continuous and where is not continuous or continuous, or where is differentiable or not. So what will you say about x0 for 26? Anything happens there? Or x sub 0? Is this function continuous?
No.
No. It has what type of discontinuity?
A whole.
It's called removable. This is a removable discontinuity. Is it differentiable? Is the function differentiable here? Anything?
I would
Go ahead.
no.
No, if it's discontinuous, it cannot be differentiable. Awesome. Is this function continuous at x sub 1?
Yes.
Yes. Is it differentiable at x sub 1? Anyone, please?
Yes.
Yes, of course. What about x sub 2? Is this function continuous at x sub 2?
No.
The function is continuous. You will not raise your pencil off the paper. The function is continuous. Is it differentiable though?
No.
No, because it has a vertical tangent. That's the reason why it's not differentiable. Good. What about x sub 3? Continuous?
Yes.
Perfect. Differentiable? Differentiable?
Yes.
Yes, there is no difference between x sub 1 and x sub 3. Good. X sub 4, continuous?
No.
No. What type of discontinuity?
Is it removable?
Awesome. That's it. Removable. Awesome. What about x sub 3, x sub 5? Continuous?
Yes.
Differentiable?
No.
No, because it's a corner. Awesome. What about x sub 6? Continuous?
Yes.
Yes. Differentiable?
No.
No, it's a corner. Awesome. X sub 7, continuous?
Yes.
Yes. Differentiable?
Yes.
No, it's a vertical tangent,
Doesn't look vertical.
like here. Yes, it
Well,
is.
it's almost vertical.
It is a vertical tangent here. Good. Last one. Continuous?
Yes.
Differentiable?
Yes.
Awesome. That's it. So which problem did you have in mind?
Can we do
Yes. The answer is yes. Just name it.
17.
17 it is.